Welcome to week 6 of remote learning. This week, we will focus on scatter plots and the correlation coefficient. Your homework this week is another Desmos activity like we did last week. And then my office hours are from 1 to 2, Monday through Friday. Again, feel free to email me at any time, and I'm happy to set up a Google Meet. I know I did that with at least one student last week, and I think it was very helpful. So you may remember looking at scatter plots maybe in middle school. Today we're focused on scatter plots and linear correlation. So we have 3 graphs here, and each of these graphs kind of represent something different. We have a green, kind of a reddish, and I guess kind of yellow, orange, I don't know. But as we look at each of these, we want to talk about the different types of correlation that we see. When we look at the very first one, if you notice, those dots are kind of, if we read left to right, they're kind of going up the hill, as I like to describe it. And so we would describe this first graph as having a positive linear correlation. If I wanted to try to draw my line of best fit, again, that might be another term that you remember from middle school. Don't judge my bad drawing. Again, not a great line, but it's decent. And we notice that line is going up the hill. It has a positive slope, and you know, it doesn't go through all the dots, obviously, but it seems to be a pretty good fit. All right, if we look at the second graph, if you notice, if we read left to right, these dots kind of appear to be going down the hill. So this would be a negative linear correlation. And again, if I attempt to draw a line that kind of fits this data, you notice that line is going down the hill. It has a negative slope. And then we get to the last graph, and I'm kind of at a loss. I don't really know what's going on here. It looks weird. I don't really know how to draw a line, and that is because there is no correlation, no linear correlation. It just looks kind of like a bunch of random dots. So as we look at each of these, again, a scatter plot is just a bunch of points that we would graph on a coordinate plane, as you can see here. Again, you have 3 options, either positive, negative, or no correlation, no linear correlation. And we'll look at more specifics. We'll talk about something called the correlation coefficient in just a minute. All right, so we're going to talk more about the correlation coefficient on this slide. The correlation coefficient is represented by the letter R. And you can see there's 7 graphs here, each with a different R value. And again, the R value, you can think of it as measuring the goodness of linear fit for the data. If you notice, the numbers range from -1 to 1, and that is true for all correlation coefficients. So it must be between -1 and +1. And just to review our inequalities, so -1 is less than or equal to R is less than or equal to 1. And again, that correlation coefficient, it measures your goodness of fit. So let's look at each of these. We'll start on the far left. If I tried to draw a line through those points, I end up with a line that looks like it has a negative slope. And if you notice, pretty much the line goes through the majority, or actually all of the points, if I could draw a little bit better. So this would be an example of a strong negative correlation. In the second graph, I can still draw that line, still has a negative slope, but now the data points are kind of spread out from that line. They're not fitting as closely as we saw in the first example. So typically this is described as a moderate negative correlation. So again, doing a lot of abbreviating here. In that next example, again, the dots pretty much look like they're going down the hill, but they're a lot more spread out in this case. So this is what we call a weak negative correlation. And then as we saw earlier, that middle one where there's just kind of dots all over the place, this is an example of no correlation. On the right side now we will switch to the positive. And so if I try to draw a line for r equals 0.3, again, this would be an example of weak positive correlation. R equals 0.8. If you notice, the points are kind of more clustered together, but still going in that upward fashion from left to right. So this would be a moderate positive correlation. And then last but not least, when I draw the line for r equals 1, notice the line goes through the points. So this is an example of our strong positive correlation. So again, we're just trying to introduce you to what correlation coefficient is. You will study it in later courses. I even reviewed this with my pre-cal students this year. All right, so let's see if we can do a little matching based on the information that we looked at. Here you're given two graphs and two different correlation coefficients. One is r equals -1 and r is equal to 0.1. And one of the key features for me is just to notice the sign of the R value. If it's a positive R value, then we should have a positive slope. If it is a negative R value, we should have a negative slope. So this one's actually pretty easy if we just use that piece of information. Now, granted, they do have the lines drawn for you, but more specifically, if you notice for R equals -1, all the dots should lie on the line. And we see that here. So we know that the one on the right is going to be R is equal to -1. Again, the dots are all on the line, and the line reading from left to right is going down the hill. The one on the right, they're pretty scattered, but based on the line here, they're saying, yeah, it's kind of having an incline here to these points. So this would be a very weak positive correlation. So R in this case is 0.1. All right, take a look at this slide and see if you can determine which correlation coefficient goes with which graph. And I'll give you a few seconds to make your decision. Okay, hopefully you're ready. If not, feel free to press pause. Again, we have R equals -1, which actually was the exact same thing in the previous example. And again, we talked about that would have a negative slope, and the point should lie along the line. So again, that will be the graph on the right. So R equals -1. And then the graph on the left, again, the dots are really spread out, but they are kind of have that upward fashion. So that would be that one's weak, moderate, somewhere in there. I'm not going to decipher which one it is. We're just trying to, again, do the matching. So this would be our R is equal to 0.5. Okay, here's another one. This one's a little bit more difficult. Both R values are negative in this case. One is -0.3 and one is -0.8. So at this time, take a second and decide which correlation coefficient goes with which graph. So if you remember, your correlation coefficients range from -1 to +1, and the closer we are to that 1 or that -1, the stronger our correlation is going to be. So if we notice the graph on the right, the dots are much closer to the line. So that correlation coefficient should be closer to 1 than the graph on the left. The graph on the left, the dots are very spread apart. And so if we look at my two values, negative 0.8 is closer to negative 1 than negative 0.3. So the graph on the right would give me that correlation coefficient of negative 0.8, and the one on the left would be negative 0.3. Again, they're both negative. They have a negative slope, but since the graph on the right, the points are closer to the line, that is why we use the value that is closer to negative 1. When they're more spread out, even though our value is negative, it's closer to 0. All right, and here's one last example. We have two R values, 0.4 and 0.9. So think about what we just talked about on the last slide and see if you can match these up correctly. Okay, again, both of these are positive correlation. Again, the closer to 1 or negative 1, the stronger the correlation. The graph on the left, the dots are much closer to the line, so that would have a stronger correlation. And so I look at my two numbers, and 0.9 is closer to 0.1 than 0.4 is. So my correlation coefficient here will be 0.9. Then the one on the right, the dots are pretty spread apart from the line, so this will be 0.4. So hopefully these examples have kind of given you a little bit more of an idea of how we can use correlation coefficients to describe a scatter plot. All right, today we're going to incorporate some review from earlier in the year. We are focusing on linear functions, so it's a good time for us to review our linear units. So let's start out with this one. It says write the explicit linear function that passes through 3, 7, and 5, 13. Many of you have different ways of finding slope. Some of you are probably giggling right now and saying, oh great, here comes Miss Shop with her table. And yes, I am a fan of a table. So I'm going to make my little T-chart here with X and Y. I've got 3, 7, and 5, 13. Again, I'm looking for the change. So to get from 7 to 13, that's an increase of 6. And then from 3 to 5, that's an increase of 2. So my slope, my change in y over my change in x, is 6 over 2, which gives me 3. Now, I know some of you prefer to look at a graph. I'm not going to do a very accurate graph, but we can do a quick sketch here. So if I plotted the point 3, 7, and again, I sketched this 5, 13, definitely not drawn to scale. And again, I'm trying to figure out, well, what is the slope of that line that connects those 2 points? Remember, we can talk about our rise over our run. And when we look at that to get from 7 to 13, that's a rise of 6, and we're going up, so that would be a positive 6. And then we run to the right, and from 3 to 5 would be 2 units. So I can get my 6 over 2, which is 3. Again, it doesn't matter how you find slope. Some of you like to use a formula that you remember from middle school. Again, that is my least favorite. I would prefer either to use a table or a graph. Now we need to write our equation. And a lot of you like that slope-intercept form, but to me, that requires a lot of work and for this problem. So you may remember a point slope. So y equals mx minus x1 plus y1. And so for this problem, we've already determined that m is our slope, which is 3. And then we've got this whole x1, y1. And we need to fill those in. And x1, y1 just represent one of your points. So for the first one, I'm going to use the point 3, 7. And remember when it says minus x1, it's really saying the opposite of the x value. So if we look up there, that's a positive 3. So the opposite of that would be a negative 3. And then it says y1, and y1 is 7. So that is one equation that you could give. A second equation, I will use the second point, the 513. So I could write y equals 3x, and then we want the opposite of the x coordinate. Since it's a positive 5, this will become a negative 5, and then your y value is 13. Again, either of those are correct. Again, this is my x1 and my y1, or for the purple, we have our x1 and our y1. Again, you could also use slope-intercept form, but to me, there's more work involved. And you know my motto is work smarter, not harder. All right, let's look at another example. It says, write the explicit linear function that represents the following scenario. Elodie earns $12.50 an hour. So for this one, I don't have really points. I mean, I guess we could think of this as a point. So if she works 1 hour, she gets paid $12.50. If she worked 0 hours, she wouldn't get any money, so that would be 0, 0. So we could make a table. I could plot points and make a graph, but literally, I think we can just translate this. And if we want to stick with our y equals mx plus b, y equals $12.50 per hour. So I'm going to put an h here for hours. Again, you could have used an x, whatever variable you would like. And as I was describing earlier, we could have her hours and her money, 0 hours, 0 pay. 1 hour, $12.50. 2 hours, $25. 3 hours, $37.50, and so on. And again, we could sketch that graph. So $12.50, $25, $37.50, and I am counting by increments of $12.50. So 0, 0, 1, $12.50, 2, $25, 3, $37.50. And we are allowed to connect the dots here because we're assuming that if Elodie works part of an hour, that she would get paid part of her $12.50. If you remember, this is what is called a continuous graph. A discrete graph is just when we have a bunch of dots. So trying to work in some review from the beginning of the year. All right, and our third review example here asks us to write the explicit linear function for this graph. And again, we already have a graph, so I'm thinking definitely use my rise over my run. And for everyone that's been annoyed that I haven't done slope-intercept, we'll go with slope-intercept this time. So y equals mx plus b. When we look at this graph, we notice that our line is going down the hill, so I know my slope should be negative, so I'm going to go ahead and put my negative. And then I need 2 good points. Well, I can see right here, that's the y-intercept. So I could go ahead and fill in that plus 10 for my y-intercept. And then I need another good point, and that looks like a good point to me. But pay attention, look at your scale in this case. If we do our rise over our run, we are actually falling down 3 units, so that would be -3. And then we're running, and you might think you need to count those little blocks, but if you look down here, notice that's a 1. So my slope, my rise over my run, is a -3 over 1. So -3x plus 10. Again, I could use point slope for this, but this one you can already see the y-intercept and the slope is very easy to calculate, so I just went with slope-intercept form. Okay, we're going to look at a real-world example. This is a scatter plot of ice cream sales. If you look on the x-axis, it is measuring temperature, and that temperature is ranging from 90 to 110 degrees. And then on our y-axis, it is measuring the number of sales, and that is ranging from 40 up to 120. And I'm going to assume that might be the number of ice cream cones that are sold. So the first thing it asks us to do is to just sketch our line of best fit. So draw that straight line through that general pattern. So we know that my ability to draw straight lines is not the greatest, but something like that. And that looks pretty decent. You've got some points above, some points below, and it looks like maybe there's at least one point that actually lies on that line. Another thing I want to draw your attention to is in this bottom left-hand corner, we're used to that point being 0, 0. But in this case, that point, my line went away. Let me draw that again. This point here in the corner is not 0, 0. In this case, that point is 90, 40. And then if I want to take another point, this one kind of looks like my line goes through it, so I'm going to use that one. So if I estimate that, that could be 102. And then for the y, maybe, it doesn't look like quite halfway, so maybe 88. And so then part B asked me to predict the possible slope. Again, I love my table, so I'm going to plug in those 2 points, so 90, 40, and 102, 88. We're looking at our change in y over our change in x. So our change in y, our sales went up 48 when our temperature went up 12 degrees. So that slope, which is our change in y over our change in x, would be 48 over 12, or simply just 4. Now, again, you did not have to use those 2 points. You could have used any 2 points. Again, I just randomly picked 2 that I could somewhat easily predict their values. It talks about interpreting the meaning of the slope, and I know that we came up with 4, but when we were looking at our slope and we were finding the change in y over the change in x, the change in y was the change in sales, and the change in x was the change in temperature. And again, we came up with 4. So what does that really mean in the context of this problem? So the way I read this is we will sell 4 ice cream cones for every 1 degree increase in temperature. And if you're like, where did the 1 come? Remember, 4 can be 4 over 1. So 4 more ice cream cones every time the temperature goes up a degree. And then the last question asks us, would the correlation coefficient be closer to 1 or to 0? And it asks us to explain. Again, 0 is that hot mess of just a bunch of random dots that really don't have any correlation, essentially. Whereas these dots lie pretty close to the line, and that line is going up the hill, so that would have a positive correlation. So this is going to be closer to 1. And again, we said that it is, the line has a positive slope, and the dots lie close to the line. Again, that 0 is no correlation. And we definitely have some correlation here. Kind of makes sense that the hotter it is outside, we're probably going to sell more ice cream cones. So hopefully that kind of gives you some connection to the real world and how we can look at a scatter plot and make inferences from the information shown. All right, so it is now time for you to do some practice. Hopefully you have been taking some notes and writing things down. So right now you will need some kind of pencil and paper if you haven't been doing that. So for question 1, or for this example, it says, examine the scatter plot below. Imagine that you drew a straight line through the general pattern of the points, keeping as close as possible to all points with as many points above the line as below. So again, we're trying to draw in that line of best fit, and then it asks us to predict a possible y-intercept and slope for the line that you imagined. And then in question number 2, I kind of went ahead and sketched the line, but it wants us to write an equation for that line. So go ahead and press pause, jot down. Again, you can just kind of with your finger think about where that line would be, and then jot down what your y-intercept and your slope for number 1, and then the equation of that line. Okay, we're going to look and see what I drew for mine, and see how it compares with yours. So here is kind of my line that I've sketched in. Be careful and notice at the bottom, the 0 actually comes in a little bit. So I think this very first dot here is about 0. Again, I've just kind of done a rough sketch. So I'm going to estimate that my y-intercept doesn't look like, if we notice we're counting by 2's here, it doesn't look like we go all the way up to 104. So I'm going to estimate that y-intercept to be 103. And then I kind of need to figure out what my slope is. And so I think I'm going to use the highlighter right now for this. So if I can kind of take my point here and think about my rise over my run. Drew a little too far there. Kind of making that slope triangle. It looks like maybe that second point that I have picked, I can kind of estimate that point to be 5/100. And then this other point that I was using, I could call that 0,103. And so when I want to find my slope, 0, 103, 5, 100. And if I want to look at that change in y over change in x, my y values, they went down 3, and my x values went up 5. So I'm going to estimate that my slope is -3/5. Again, I can see that here. I'm going down 3 units, and I'm going to the right 5 units. Again, you may have something different. That's totally okay. We're just estimating. So number 2, I've already done the first part. I've sketched the line that you imagined, and then we write an equation. This time it makes way more sense to do slope-intercept form since I've already identified the slope and y-intercept. So in y equals mx plus b, so y equals, we've got a -3/5 x plus 103. So again, just kind of connecting some prior learning to our scatter plots. All right, and this will be our final practice for today. I have given you 6 different graphs and 6 possible correlation coefficients, and this is matching. And so I know that when I tried this, I kind of started thinking about which ones are really strong, which ones are really weak, would I have a positive slope, a negative slope, and again, that kind of goes along with whether your correlation coefficient will be positive or negative. And then also looking at, are the dots going to be really close to that kind of line that I'm thinking about, or will they lie kind of far away from it? So at this time, press pause, see if you can match these up, and when you're ready to continue, press play. All right, if you are not ready, again, please press pause. I'm going to move on to the next slide and let you see what I came up with and see how yours compare. So for mine, it helps me to kind of draw in the line. So I try to sketch a line for each of the graphs. Again, it's a sketch. I'm not saying it's perfect. And then kind of the order that I did these, like letter B, for example. B was 0.97. And so we know that that 0.97 is going to be a really strong positive. And so I look for the dots that were going up the hill and that they were pretty tight, okay, pretty close together. And so that's what helped me find that one. And then next I looked at part C. I got that negative 0.94. So again, I knew those dots were going to be really close together, but this time they were going to be going down the hill. So that's what drew my attention to that very first graph. The next one that I came up with, actually looked at answer A, or excuse me, choice A, when we had that 0.05. That's really close to 0. So I knew that was kind of what I call that hot mess graph. We just got a bunch of random dots all over the place. And that's what helped me figure out that that third graph on the first row was going to be part A. And then from there, I just looked at the remaining ones. Letter E was the only other positive. And so for the graphs that were remaining, that's how I kind of determined which one was E. And then D and F were both negative, but negative 0.49 was closer to negative 1 than negative 0.25. And so that's how I kind of decided which graph should be letter E and, or excuse me, not letter E, which graph should be letter D and which graph should be letter F. Again, D, the dot should be kind of closer, clustered toward the line, closer to the line, whereas F was going to be more spread out. So hopefully you did okay with those. Again, if you have any questions, please reach out to me. Well, that concludes our lesson this week, a little bit shorter. Last week we did a Desmos activity. Not many of you have completed that, so please make sure that you go back and give that a shot. Some of you sent me some emails and were concerned about how were you to submit it. Again, when you log in through your Google account, it records your name and then I can see your responses. One person did sign in as 123 instead of using their name last week, so I'm not sure who did that to be able to give you credit for it. So again, please, please, please make sure that you sign in through your Wake County Google account, or at least type in your full name. So you're going to go to student.desmos.com, and our code this week is BHY8YC. Hope everybody has a great week, and I look forward to hearing from some of you. Take care.